still with me.
Hello there, students, and welcome to class. Thanks for being on time. I definitely appreciate that. As you will notice, I am not here today. So, it doesn't mean I can't teach you with the wonders of technology. I'll still be teaching you, my wonderful Math 8 students, I'll be teaching you probability today. So, hopefully you have a sheet that looks just like this one in front of you, and why don't you spend the time right now to write your name in this space right here. You know it. Put it down right there. And remember, I want a last initial, right? So in my case, it would be Patrick W. Block C. All right, let's start with the important stuff. The name of our teacher today. Has she introduced herself to you? She's a little shy. Her name is Miss Burks. Write it down, everyone. Now, you'll have to ask her. I'm not actually sure. Does she like Miss? Does she like Miss? Does she like Mrs.? Is it Ms.? You better ask her. Got that figured out? Great. Now, one or two of you might be a little skeptical. You might be like, who is this woman at the front? Is it really this Miss Burks, or is it imposter? So I ask you, does the woman in front of you look like this? This is Miss Burks. She should look just like this. Now, some words to describe this woman. The things that come to mind to me are wise, intelligent, beautiful, charismatic, friendly, fun. Pick 3 of your own words or borrow some of mine and write them in the spaces here. Make sure they're nice words, everybody. Okay, I'm sure Ms. Burks is loathing me right now, so let's move on. We're actually now going to talk about probability. So I know you've heard this word before, probably you've studied it a little bit in elementary school before. So if we're going to talk about probability, probably the first thing we should discuss is, what is probability? Anyone got the answer? Well, sadly I'm not there to listen to you say it, so I'll tell you what it is. Probability is the likelihood, or another way people often say that is the chances, the likelihood or chances of something happening. Okay, so yeah, you should write this down too. The likelihood or chances of something happening. So what we're going to figure out today is, how do you figure out the probability of something happening? Okay, first of all, what are outcomes? Outcomes are the different ways an event can happen. The different ways an event can happen. Miss Burks is going to think that this is our typical math class and I sit at the front giving you notes and you write them down. Please tell her that I think I've given you notes 3 times all year. The different ways an event can happen. Okay. So for example, okay, just hold on. Let's do favorable outcomes first, then we'll go back to examples. So what are favorable outcomes? Favorable outcomes are the event. It's the event or events. This means the event or events that you are interested in. I'll put that you are actually interested in. Alright, we need examples. So, for example, if we are talking about a coin, here's our coin right here, you might recognize it, and we're talking about the probability of getting a tails on this coin. The way you write that, by the way, is probability, big P, of getting tails. That means probability of getting tails when I flip the coin. Okay, so one thing we learned about is outcomes. Those are the different ways an event can happen. So if I was to flip this coin, you don't need to write this down obviously because you don't have this page. If I was to flip this coin, what are the possible outcomes? How many outcomes are there? There's heads and there's tails. And I know, some smart aleck has his hand. Mitsu, put your hand down. I know you're going to say, What about if it lands on its side? This is so improbable and negligible a possibility. We don't consider that. It doesn't happen. No, there's no time in humanity that someone's flipped a coin and it's landed on its side. And Okan, even though you're yelling, I saw it happen once, I saw it, you did not. Okay, it's not true. So the outcomes are heads and tails. The favorable outcome... Oh, by the way, is anyone yelling, why is Mr. Waj writing favorable with that U in there? That's wrong. No, it's not. If you want to know why, talk to Ms. Burks. She knows way more than I do about spelling and about grammar. Although, remember, I am a good speller. I declare I'm a good speller. Favorable outcomes. I shouldn't have two. There's only one. What's the favorable outcome? What's the one we're interested in this case? In this case, the favorable outcome is tails. That's what we actually want to, that's what we're looking at. What's the probability of tails? Now, this word favorable, usually when you hear the word favorable, it means something good. I just want you to be clear that favorable in probability sense doesn't necessarily mean good. What if I was playing this great game with my friend? Oh, I play this all the time. It's so fun. We flip a coin, and if I get heads, he gives me $5, and if I get tails, he chops my finger off. Okay, now if I was to flip a tails, if he wants to know what the probability is of getting tails and chopping my finger off, I hope you'll agree with me, it's not favorable that I get my finger chopped off. It's not favorable to get a tails. But if that's what he's interested in, what the probability of getting tails is, we still call it favorable. Okay, it has nothing to do with how good of a situation it is. The favorable just means the thing you're interested in. Does that make sense? If not, ask Ms. Burke. She understands completely. All right, let's go back here. So we've talked about outcomes, we've talked about favorable outcomes. Now we need to know what the probability formula is. So the way you figure out probability, this is important, so I'm writing it in red. Probability. The way we figure out what probability is we take the number of favorable outcomes, oh no, it doesn't fit in the box, and divide by the total number of outcomes. So I know you all know what the probability is of flipping tails, right? And the reason for it is because the probability is, I'll just put P instead of probability, the number of favorable outcomes, in this case 1, divided by the total number of outcomes, in this case 2. So the probability is 1 over 2. Okay. So what else do I want to say? Okay, so let's flip it. So go ahead, make it. I know this is going to be loud. Just keep your voices down. Don't scream. Pick heads or tails. Everyone got it? Don't scream when this happens. We'll see if you got it. And there you go. Did you win? Well, if judging by probability, how many people in the class should have won? About half the people. Did half the people exactly win? Probably not, actually. Chances are that you were actually a little bit off. That's the funny thing about probability. Usually, you don't actually match the probability you expect. This is the difference between theoretical probability and experimental probability, and we'll talk about that some other time. Okay, let's say that I flipped it this time and I got heads, because I did. And then, so I'll write that down. The first time I flipped it, I got heads. And then I flip it again, I get heads. And I flip it again, I get heads. I don't want to actually do this every time because I can't guarantee I get heads, heads, heads. Okay, now I'm going to flip it. I'll do it again. Heads. So I've done it 4 times in a row. Now I'm going to flip it. I really will flip it this time. What's the probability of getting heads this time? 1 over 2. It's still 1 over 2. Okay, so let's flip it. And I get heads again. Oh, wow. That was lucky. So I got heads again. What's the probability of getting heads this time? I mean, I've gotten a lot of them in a row here. Is it getting less likely as I get more and more? No, the probability is still 1 over 2. Let's see if I get it again. No, I didn't. Okay, so my point is, no matter how many times you get heads, 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 each of those events are independent of another. So even if I got 5 in a row, or 6 in a row, or 12 in a row, the probability of getting heads the next time would be 1 out of 2, and the probability of getting tails would be 1 out of 2. Sometimes people think, well, I got a whole bunch of tails in a row, or a whole bunch of heads in a row, so I think it's less likely. That's not true. That's not true at all. And unless, of course, it's a weighted coin, okay? Don't yell that out at Miss Perks either. We don't need to hear all these examples. Alright, back to this page. We've got the probability formula. Coin, what's the probability of tails? I believe we did that. We said the probability is 1 over 2. Next question. How can probability be expressed? Well, it can be expressed in this form. What do we call that? We call that a fraction. And I'm going to add a couple words in front. A lowest terms fractions. I mean, it doesn't have to be lowest terms, but I will expect you wonderful grade 8s to put your fractions in lowest terms. What does that mean? It means you need to simplify them. You need to put them in lowest terms. You need to, the word I never say, remember the word I never say? Reduce them. If Miss Burks wants to know why I never say reduce, someone explain to her. Okay, well, how else could you express a probability? So one way you could do it is as a fraction. Another way you could do it is as a decimal. So we could switch this fraction into a decimal. Anyone know what that is? You should. We did this earlier in the course. If you have a fraction you want to turn it into a decimal, just divide. 1 divided by 2. But I imagine most of you already know that 1/2 is exactly the same as 0.5. So these are the same thing. There's a third way you can express a probability. You can express it as a percentage. Do you know how to switch a decimal into a percentage? I'll give you a hint. You need to use one of our pedal diaper rules. Remember the pedal diaper we came up with? Pedal diaper. Now Miss Burks is concerned about my teaching methods. If we're going from a decimal to a percentage, we're going to move the decimal to the right. How many spots? Always 2 spots. So 1, 2. You already knew this anyway. 1/2 is the same as 50%. Just so Miss Burks understands, if we're going from a percentage to a decimal, we move to the left. Hence the pedal diaper rule. Brand new this year, figured out by my wonderful grade 8s this year. Okay, dice, or die, if it's just one dice, it's a die. So I have a die here somewhere, and the first thing we want to take a look at is what's the probability of getting, what is it? I want to know 5, even, and then 9. Okay, so what's the oh, there's already a 5 there. What's the probability of me rolling this die and getting another 5? Alright, I know you probably know the answer, but just to make sure, the probability equals the number of favorable outcomes. How many favorable outcomes are there? I bet there's at least one person in the class here who thinks the answer is 5 because we're looking for 5. That's not true, right? How many favorable outcomes are there? Just one. What is the favorable outcome? 5. So there's only one favorable outcome, which is 5. And how many outcomes are there total? 6. What are they? 1, 2, 3, 4, 5, 6. When I roll this die, I could get 1, 2, 3, 4, 5, or 6. So the probability of getting a 5 is 1 over 6. What's the probability of getting a 2? 1 over 6. How about a 3? 1 over 6. Okay, they're all the same. The next one was the probability of getting an even number. What are the even numbers? The even numbers are 2, 4, 6, 8, 10, 12. 4. So what's the probability of getting an even number? Well, the first thing we need to look at is how many, well, let's do the bottom first. How many outcomes are there total when I roll this die? Same, 6, 1, 2, 3, 4, 5, 6. How many favorable ones are there? In other words, how many even ones are there? 3. 2, 4, and 6 are all even. So my probability is 3 over 6. Is Mr. Wadge happy with this answer? No, he's not. Why not? I want it in lowest terms. So what would you do? You would divide this by 3. I would divide this by 3. You would end up with the answer 1 over 2. Okay, the last one I had on the page there is, oh, you should be writing this down, right? Because it's on your page. The probability of getting a 9. Okay, I know some of you are yelling and upset because there's no 9 on the die. Let's just think about it for a second. How many outcomes are there? 6 again. 1, 2, 3, 4, 5, 6. How many favorable outcomes? In other words, how many 9s are there on that die? There's no 9 on that die. There's 0 of them. So the probability is 0. Okay, good. Alright, let's roll the die. Everyone pick your number. Keep it down, no screaming. You got your number? Alright, here we go. The winner is 1. Good for you. Put your hand up if you won. Good. Guess what you win? Nothing. 2. You win 2. You also win nothing. Alright, we are almost done. So we already did this. You should have filled it in very quickly. Probability of 5 was 1 over 6. Probability even was 3 over 6, which is the same as 1 over 2, and probability of 9 is 0 over 6, which is the same as 0. Notice I wrote them as fractions. I could have written them as decimals, but fractions are my preference, to tell the truth. Okay, spinner. We're going on to spinner. We're going to figure out what's the probability of red and what's the probability of color. So here we go. We got a whole bunch of colors here. I'm terrible with colors, as I think I've told you. So red, orange, blue, green, darker green. This is black. This is purple. What's this thing? Miss Bergs, help. Is that indigo? Is that violet? I don't know. You name it something like that. So what was the first one? Probability of red. Okay, can you do it yourself before I write it down? What's the probability of getting red in this case? Well, how many outcomes are there total? How many total outcomes? 1, 2, 3, 4, 5, 6, 7, 8. So the probability is something over 8. And how many red ones are there? Just one. The probability is 1 over 8. And the other one I had down there, sorry, that was probability of red. The other one I had was probability of getting a color. That's weird. Probability of getting a color? How many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. How many favorable ones? Is this a color? Yeah, it's a color. How about this one? Yep, this one. Yeah. They're all colors. So the total number of favorable ones is 8 out of 8, which is the same as 1. Ready to spin? Pick your color. It's hard to win this one. You got a 1 in 8 chance. It's not so good. This time, if you get it right, I will allow you to say Yahoo about that loud, okay? Because this is a big one. Here we go. Good luck to you and congratulate. Oh no! Of course, it has to be the color. I don't know what it's called. Way to go to everyone who picked that. Okay, back we go. And this is 1 over 8. And this is 8 over 8, which is the same as 1. Okay, probability can be small as, what's the smallest probability you can have? Well, we saw it could be 0. Up here we got 0. Can it be any smaller than that? Any smaller than that would be negative numbers. Does it make sense to have a negative probability? No. The smallest you can have is 0. What's the biggest it can be? Well, if you're talking about percents, the biggest it could be is 100%. If you're talking about decimals, the biggest it could be is 1. So it can go from 0 to 1 in terms of decimals, or 0% to 100% in terms of percents. Okay, what does it mean? Let's just add this down here. What does it mean if something has 0% probability of happening, or the probability is 0? That means it will not happen. It's just, it won't happen. It's not gonna, it's impossible to happen. Right? It will not happen. There's no probability, there's no chance it is not happening. What's it mean if something has a probability of 1 or 100% chance? It will happen. There's no doubt about it. It's going to happen. That's why weathermen, when they say there's a 100% chance, ooh boy, that makes me nervous, because it must happen if they say that. When they say there's a 0% chance, that means there's no possible way it will rain that day. And I don't know. Sometimes it seems like it rains even when they say 0%. At least in Vancouver it seems that way. I think we're done, except for one last thing I wanted to show you. I should have set this up beforehand, so I apologize. I just thought it while I was doing the video. If I drew something like this, ignore that little mark there. I can get rid of it. Okay, and let's put just some numbers in here. This is section 1, this is section 2, this is section 3, and I've got a spinner. That's a terrible spinner, and I'm going to spin it, and I want to know what's the probability of getting a 1. What's the probability of 1? Okay, well, let's try our probability formula. How many total number of outcomes are there here? 3. 1, 2, and 3. And how many favorable ones are there? Just 1. The 1's favorable. So the probability is 1 over 3. Okay, that's it. Video over. I hope someone's yelling. No yelling. But I hope someone's saying, that's not true, that's not true. That's not true, is it? What's wrong with that? You cannot do that. You can't just say 1 over 3. Why not? Because all the outcomes must be equally favorable, equally likely. You need equally likely outcomes. These are not equally likely, right? It's like saying, I don't know, Mr. Waj is going to have a weightlifting contest with Damian. You know Damian because his sister is sitting in the class with you. If we were having a weightlifting contest and we wanted to see who would lift more weight, do you think the chance of me winning is 1/2, 1 out of 2, because there's 2 people, me and Damian, and the favorable probability is 1 for me? No, the probability is not 50-50. Damian is 5 times stronger than me. He's going to win the contest. So you need to have equally likely outcomes. So let's go back to this question. This is wrong. What is the probability of getting 1? Anyone figure out what it is? The probability is actually 2 out of 4. How come? Anyone see why? Because if I was to draw this line right here and move this one up here and draw another one, because this whole section was 1, so that's fair, just put it 1 there and 1 there. How many favorable outcomes do I now have? 2. How many total? 4. So I have 2 over 4. Happy with this answer? No, should be 1 over 2. Okay, so equally likely is really important. I think we are now done. Thanks for watching. Thanks for listening. Thanks for being good students and doing your work in class quietly. I want a good report from Miss Burks. Okay, have a great weekend. I will see you next week. The worksheets that Miss Burks assigns are due. I think you could get them done by the end of class. If you don't, they're for homework. Okay, bye-bye.